In this video, we'll go over an introduction of the divergence test for infinite series. Now, the divergence test states if the limit as n goes to infinity of a sub n is not 0, or that the limit as n goes to infinity of a sub n does not exist, then the infinite series from n equal to 1 to infinity of a sub n diverges. So this means that if the limit of the sequence of the terms is not 0 or that the limit does not exist, then the series composed of that sequence of terms must diverge. The contrapositive of the test is also true, which is if the limit as n goes from 1 to infinity of a sub n converges, then the limit as n goes to infinity of the sequence a sub n exists, and that the limit as n goes to infinity of a sub n must not only exist, but it must equal to 0. Now, one important thing to note is that the converse of the statement is not true. This means just because that the limit of the sequence exists and is 0, this does not mean that the corresponding series will converge. Let's look at a couple examples. Now, determine whether the following series diverge or state that the divergence test is inconclusive. So let's say if we had the series as k goes from 0 to infinity of k over k plus 1. Now, since the limit as k goes to infinity of k over k plus 1 equals to 1, you could use, let's say, L'Hopital's rule for that. Then by the divergence test, the series must diverge. Now, for another example, determine whether the following series diverge or state this divergence test is inconclusive. So let's say if we had the infinite series from k going from 1 to infinity of 1 over k. This is a case where it's inconclusive just because the limit as k goes to infinity of 1 over k is equal to 0, this does not mean that the series will converge. So the test is inconclusive. So the test will only help you to determine if a possible series may diverge. It will never tell you if the series converges.